All right, here goes nothing. Okay, a pitcher pitches a .145 kilogram baseball at 35 meters per second, and the batter hits it directly back. Okay, so if this was I don't know if this is a negative velocity, that is, let's imagine that the pitcher is pitching it this way, right, at negative 35 meters per second. That means that the batter hits it this way at positive 42. Okay, the key concept here is that these things are in different directions. Okay, so as tempted as you are to say that the change in velocity is something like 13, understand that it's not, that it's a big change, right? The change in velocity for this thing is final minus initial, right? So it's going to be 42 minus a negative 35, right? So that's going to be 77 meters per second, right? Okay, that's the key concept. So basically we're just going to go force times time is mass delta V. The force is 892 newtons. The time is, I guess that's what we're solving for, right? The mass is 0.145. And then the delta V is this big thing there, right? 77 meters per second. Another way, by the way, to think about the change in velocity, right, is if we make a number line, right, here's 0, right? The pitcher pitched it at negative 35. The batter bats it out to the outfield at 42, right? This change here is positive 77. Now, by the way, I could have just as easily made the pitcher's pitch positive and the batter hitting it in a negative direction. The key is that they're in opposite directions. Okay, let's see if this works here. So 0.145 times 77 divided by 892 is, for the time, I'm getting 0.0125168 seconds, approximately. This is with sig figs, right? Okay. Yeah, I hope the audio on this works.